And welcome back. So this is part 2 of chapter 2 of Python Essentials 2 course. Now in this one we will be reviewing the good old exceptions or errors. So this talks about how we can try to make it so that our programming can continue to function after handling an error. And we'll talk about how exceptions are created and the various hierarchy of exceptions and modeling. So the last video we talked about strings, characters, standards for representing character types. We then did a comparison between what functions and methods we can use with strings exactly the same way we would do with lists. So it was a recap from Python Essentials 1 and delved in a little bit deeper. So this one we're going to talk about how exceptions occur and some of the reasons why they occur. Like in the example here is a fairly basic square root function and the problem is we don't actually give the user a sufficient prompt. We just say enter x. We don't tell them what we expect x to be. So they could put in something that the float type of variable isn't equipped to handle. So this is one of the ways things can go wrong. So when we create our routines, we need to ensure if we are trying to get user input that we give the user enough information so that they can answer the question with the correct data that we're after. We then have to have a look at how we can handle the process if they put in something other than that. So an exemption in Python can be handled one of two ways. It can be terminate the program and send an error message up to the console, or the error can be handled by the code and the actual program resumes processing from the next step. So the types of error messages that you can get, for example, value errors, zero division error, index errors, always come with the name of the error, and a descriptor giving you more details about what the error is. We approach error handling by putting in a try and except branch. So under the try keyword, we place any statements that we are concerned about that may generate an exemption, and what occurs if an exemption is raised is it will go and try to execute the statements in the except branch and try to resolve the issue there. If it can resolve it, then it resumes normal programming. So this is what we want to occur. Now, it may be a case where some of the lines in the try branch are never executed, because once that exemption is raised, no other statements in that branch will be executed. It will then jump over into the exception key area and execute that. So it is handled this way so that we don't try and force any statements that would increase the problems. So the except branch is only activated when an exemption is raised within the try branch, and not all statements will be executed necessarily. When either of the try or the exempt branches are executed successfully, then programming resumes under the normal pathing. So the next command to be executed would be the next part of your program. Now, one of the things we can do is specify a exempt condition, which means it's going to match the error type, and then execute the code associated with that error type. Now, one of the reasons we do this is by providing different controls to handle different types of errors, we get better control and resolution of the problems. It also allows us to get more information on the precise errors that occur, because we have specific information being generated based on the error type that is being generated. So it will match one of the exempt branches, the named exempts, and it will execute the code associated with that. So the normal ones that occur under the first example, but this time what we're doing is we've got specific statements that we want to run when specific error codes are generated. You put as many of these in as you feel necessary, but I would recommend you use this option of having a default exemption which doesn't have any exemption named against it, and that set of code will be executed if none of the above are matched. So Python has 63 built-in exemptions, and if you look at it, it's like the roots of a tree. So you got the main tap root, and then all your little branch roots that come off of it. So base exemption is the most generic exemption code that you can match against. It basically has everything else deriving from this. So as you come down, you get more specific about the type of error. So you can see here we have 3 different exemption types under base, and then under that we have another 3, and under that we've got others listed. So as we come down each layer, we get more specific about the types of exemptions being generated, and when you match for example, the lookup error, it'll match any and all error codes that are derived below it. So this is the generic type for all of these specific ones. And the same goes for exemption. So all of these would be captured by that generic code. So when you do your try and exec branches, you want to put the most specific statements first and then the generic ones last, as it will find a match, then execute that matches the code, and it won't search any further. So the order that you write them in your statements is important, because if you put a generic one up the top, like if we had just the default one, instead of being down the bottom, we had it up the top, that would match every type of error code, and that would be run all the time. The specific ones wouldn't get a chance. So if you want specific error types to be handled with the same code, the same statements, then you can list them one after the other inside parentheses, separated by commas. And that means if it matches any one of these exemption types, those statements will be executed. Doesn't have to match all of them, it's just got to match one of the names. So when we're doing testing, we may want to be able to trigger the error types, and we can do that with the raise keyboard. Now, depending on how we execute this keyword, we can actually get it to generate a specific type of error, or we can get it to repeat an error that has been just executed. So in this one, bad fung, raise zero division error. So in this example, we're actually raising a specific type of exception error whenever bad function is run. And by doing this, we can test our error handling and whether or not that particular type of error will break our program. Now, in this one, we've got two try exempt scenarios. One's defined under the function and one's in the main programming body. And what this will do is, depending on what occurs when we call the function, it'll tell us an error message and then re-raise the exact error again as part of the return. So here we're in the main body, we're calling the function. The function, as it n is 0, we're dividing by 0. So it'll print, I did it again, and then raise a division 0 code, which falls under a different, is arithmetic error above or below that code. Check your memory or skip back. It's up to you. the next bit here before we go through some examples is how we can evaluate conditions, and if a condition is true, then it does nothing. If the exemption is false, then it raises an insertion error. So what is true? So general evaluation conditions apply, but a non-zero numeric value is also considered true. A string that has a value in it is also true. Any other value that is not none is considered true. So this evaluation process is to assist in the exceptions and validation. It does not replace them. It's there to guide the steps. So if your data is being handled correctly in a series of steps that you believe it should behave in, then this will do nothing. If it's returning a data set that isn't part of your expectations, then it'll kick up an error for you and find out. Now, for those that didn't kick back a couple of slides, there's our zero division error, which is part of the generic arithmetic error. So we would have gotten 2 error codes out of that previous example. So there's 63 built-in error codes. We're going to go through some of them, not all of them. We'd be here for a very long time if we did that. But we'll run through a few to give you an idea of where they sit. So in red we have the error type. The location is coming down the tree from base, exception, and then you can see where it sits, and gives you a descriptor about the exemption. So I'm not going to read them all for you. I think you can read it off the screen. Press pause, can do that. Alright, so each exemption has a location within the hierarchy of exceptions, and each of them have a descriptor that triggers them, if you like. So assertion error is raised when an argument evaluates to false, none, or zero. So these give you an idea of what triggers each error or exemption. I'm going to use those words interchangeably through these. Keyboard interrupt, lookup errors, memory error, overflow error. Again, all of these are in the documentation for Python. If you want to know about them, I would say you would want to have the reference material available so that when you're debugging or generating some testing procedures, you have this available to you so that you understand where they are in the process. And to find that, you can go to docs.python.org, and under the version that you're using in the library, exemptions, and you'll get the full 63 built-in exemptions. So that was a very brief introduction into how we can set up our programming to handle potential exemption errors being raised and how to handle them. And if we put a little bit of thought into this process, we can get it so that we may generate an error, but it doesn't necessarily mean it's going to crash our program. So the idea is put in methods to handle issues that arise and keep the program running. The last thing we want to do is to have it terminate, because generally speaking, our pesky little users get upset when we do that. So, I thank you for joining me. That will be where we end today's session. Until next time, thanks for joining.